with Mel Amundson. We are both with NTT out of the Denver area. This is webinar number 2, and perhaps you attended webinar number 1. Webinar number 1 was an overview of all the changes in the NEC, and we talked quite a bit about just some of the general philosophy behind some of the changes. Today we're going to get down more than nitty-gritty, chapters 1 through 4, and we'll hit all that we can. There are a lot of changes to cover, but we'll certainly cover many of them. These are the proposed changes that we're going to talk about today. We'll talk about when they become official. But at this point, we have to say these are the proposed changes. But we've got a good handle at this point on what they're going to look at. There will be a third webinar, as you can see down there. I'll give you the date at the closing of this webinar. But it will cover chapters 5 through 8, as well as the new articles that we'll find in the code. And so I am Randy Barnett, and I'm a 40-year electrician and program manager for codes and safety here at NTT, and have worked as an electrical inspector and foreman and journeyman and so forth, and a lot of industrial construction and maintenance. And I'll turn it over to Mel at this point and let him introduce himself, and then we'll jump into the info.
Hi guys, Mel Amundson here. I want to say hi today. Glad to see everybody out here. Nice group. We're often into the changes 1 through 4, kind of give you an overview of what all the changes are throughout these chapters. We're going to kind of take off and hit all the major ones. There's a lot of changes that did go on within the code, but given our time constraints, we're going to hit the high points on this one. So please, if you got a question, please send it in. We can talk with those and maybe perhaps deal with those a little bit later, as well as we've got some full-blown programs later on you'll get to see. A little bit about who I am. I said my name is Mel Amundson. I come out of the utility industry, number of years in the utility industry, and then went on to run my own electrical contracting company for a number of years. So I'm like Randy, 30-plus years in the business out here, so deal with it a lot. I deal a tremendous amount of time with the codes and so on with that. So anyway, with that, I'll give Randy, you want to hit the next slide there?
Alrighty. The code itself, and I mentioned the proposed changes, the code will not be issued by the Standards Council until August the 4th is the scheduled date on that. The PDF version of the code will then be available on August the 10th, according to NFPA. August 24th, the code will go to will be at the American National Standards Institute, ANSI, and will become ANSI approved on August the 24th, and available then for adoption by the various states. And I know several states are already in the process of working through and adopting the code within their jurisdictions. The softbound version that you're most familiar with will be available September 1st. This is the same one we give out in our classes, and that's the great big thick book. And this year will have the black and the red cover on it. The loose leaf version will be available 9/15, and then of course people ask about the handbook, and that's showing up by NFPA as being available for November 18th. And at this point, I'm going to go ahead and turn it back over to Mel and let Mel take us through the definitions then.
All right, let's take a look at a few of the new ones, definitions that have popped up in here that are some of the ones that are actually some changes. Accessibility out here, readily accessible here. We're talking about somebody who, they got to get out. Is it a minor problem? Is it a major problem? But can I get to it? As you can see, we're looking at it must be readily accessible through no use of tools out here other than keys. You can still use the keys out here. No ladders and so forth on that to get to it. So once again, trying to make it so you can get to it out there. So next one out there is for new code groups out here. An organization, the field evaluation body. What we've got with this is who can approve the equipment, who can process, who can evaluate it. You also see tags out here from these people. And so out here, our authority having jurisdictions are people who are looking for these kind of tags these days to help support their, what they get into and as they look at the equipment and gear. So what are we talking about? We're talking about organizations like UL, CSA, your Canadian standards groups out there. You've got NTRLs actually in your nationally recognized testing labs here in the U.S., such as MET and a few of the other ones that we'll see from time to time. So next definition out here is hazardous locations, and they really are new definitions, but they've moved. They used to be out in 500.2 was where they were. They have now all moved to 100. And this is to comply with the styles manual out here. So you're going to have to go find your definitions out there, especially when you're doing the hazardous work out here, where different classifications are going to be stuck out there in that one. So next one out here then is my receptacles. What they're doing, they're redefining these as I can also have equipment that directly connects. It's a modular type design where equipment will mate up as you just mount it, plug it in, and so on like that. You were seeing this in some fan and light type fixtures where all comes as one piece. You mount that into your receptacles or your outlet boxes, and then you can just plug your gear into that. So, but that's some of the new definitions out here. Next one out here is our voltages. They they haven't recreated the voltages, but they're once again redefining our nominal voltages: 120, 240, 480, 277, 600. Voltages we've all used all along for many, many years. A key new point is down here that they are now giving you a nominal voltage for batteries. And here, if you'll see in my informational note number 3 down here, got battery units may be rated at a nominal voltage of 48, but the charger can operate at higher voltages. So and that's typical. What's seen in different units like this is charging units and so on that we see. Let's get charges it higher. We may see it up as high as 60 volts, to maintain the charges on the batteries, but not unexpected. The nominal voltage is still 48 volts on this guy. So what do we got next there, Randy? I think is
let's do this. We've had a little change to electrical connections in 110.14. Let's do a little bit of a poll here, and just for kicks, how many of you would say that you currently torque all or at least most of your terminations? If you go to that breaker and there's a torque value on it, you actually pull out a calibrated torque screw or a calibrated torque wrench or whatever and torque it down to that specified value. And maybe a lot of us, many times I said, oh, my elbow's calibrated, it's all right. I give you 5 more seconds. 5, 4, 3, 2, 1, and there we go. Probably looks like about 2/3 of the folks do not, use any calibrated tools to torque terminal connections. And there's a reason, an issue for that. Let's take a look at that 110.14. And the problem is they did a study and they found out that 75% of all terminations are improperly or do not have the proper torque on them if you do not use a torque screwdriver or a torque wrench of some kind. I would have thought it might even been a little bit higher than that. But anyway, and we know there's a problem. If I don't properly torque a screw, that manufacturer came up with a torque value on that breaker or disconnect or whatever that lug is, and they came up with that value for a specific reason. If I take 2 different types of metals, a copper wire, and put it underneath that metal screw, and then it heats up and expands, and then it cools down and contracts as current passes through that wire and that metal and so forth, they're going to expand and contract at different rates. And so wires will tend to work themselves loose underneath terminals over a period of time. And you may be well aware of that if you've ever gone to a really, I'm just thinking I recently went into a really old panel board from 1948, and everything in there was really loose. So things will loosen up on their own. So that torque value is there for a reason, and the code is now saying we need to pay attention to that. So the way that it is going to read, it says where a tightening torque is indicated as a numeric value on equipment or in the installation instructions provided by the manufacturer, we're going to have to use a calibrated torque tool to achieve the indicated torque value, unless the manufacturer says something different. So 110.14 is an interesting change then. New requirement on arc flash labels, 110.16. In fact, we've got a whole new subsection, B here. And this is for other than dwelling units, and for services at 1200 amps or more. It says that we're going to have to comply with all the requirements of 110.16a, which means that on equipment that is likely to require servicing or maintenance after installation, we have to put an arc flash warning label on it. And so on this the service equipment then, 1200 amps or greater, which obviously would be other than dwelling units, we're going to have a label, and it's going to have to be either field or factory marked. It's going to give us the nominal system voltage and the available fault current at the service. Now, if you think about that, we should know that during the initial design and installation of the equipment, shouldn't we? Because we have to specify equipment for certain rated short circuit values. So we have to know how much fault current is going to be available into our equipment. We also have to list on this label item number 3, the clearing time of the service equipment over current protector device, and based on that amount of fault current, and then we have to have the date that the label was applied. And Mel, I'll turn it over to you for some information out of chapter, oh no, I'm sorry, I've got 110.26 yet here. This is an interesting one. We've always installed equipment, of course, above suspended ceilings and down in crawl spaces. And the problem is, quite often, we're in violation of 110.26a for clear working space about our equipment because of that suspended ceiling or that crawl space. So what they're doing is they're saying, look, let's take and come up with a new subsection under A here, and we'll call it number 4, and it'll be limited access is the term we're going to use. So we're going to say that this equipment operating 1,000 volts or less, nominal to ground, that's likely to require examination, adjustment, servicing, or maintenance, and so forth, while it's energized, even though we don't want to do that. But if we need to get in there and do some troubleshooting or take a clamp-on ammeter reading or do a visual inspection or something, if it's located within one of these spaces, crawl spaces or above the lay-in or suspended ceilings, there are 4 requirements we have to meet. Now, I'm going to tell you, I'm just going to talk about those 4 requirements. We're not going to put all of that text up on the screen. But really the key is, it's the size of that opening in that suspended ceiling or down into that crawl space is the change. So that opening into that lay-in suspended ceiling is going to have to be at least 22 inches by 22 inches. Well, that shouldn't be a problem for most suspended ceilings, right? 2 foot by 4 foot, so 24 by 48. So we've got to have at least 22 by 22 for the suspended ceiling, and for the crawl space, the opening end of the crawl space will have to be 22 by 30 inches. And that's that area where we're going to go in and access that equipment then. The other 3 items that we have to comply with really result right back to clear working space about equipment. It says we have to have a width of working space of 30 inches or more, or 30 inches of the width of the equipment, whichever is greater. And so that's not really a change from working space requirements. All my enclosure doors have to be able to open a full 90 degrees up there in that overhead. That's no change. And for the spaces in front of the equipment, that goes right back to that table 110.26A1. And that's where we come up with that 36 or 42 or 48 inches, whatever the case is. So that is the changes in working space requirements, called limited access, and it's based really on the size of those openings into our suspended ceiling or down into our crawl spaces down below. Now we'll move on to Chapter 2, and I'll turn that back over to Mel.
All right, here we're coming back again. Once again, 210.8 GFCIs out here. We're looking at, GFCIs have been around for many, many years. Just that everybody tends to push the envelope a little bit, so they kind of tend to redefine every time and go around. So they defined one of the things out here is the shortest distance of a quarter appliance connected to the receptacle. So, and not going through anything, not piercing a wall or anything like that, and giving you a definite, defined area. Where does it go for the measurements? My measurement for the sink if you look at under dwelling units on number 7, there it defines the sink, as you can see for our picture right there. It is measured from within 6 feet from the top inside edge. Now, who in the world decided to measure from the inside edge or from the flange, from the sink? Somebody evidently has tried that. So they're defining it now. So it's once again definite. And you can see also in our little picture there, the receptacle distance. You can't drill a hole in the wall and say, okay, hey, we shorten the distance to make it. So the GFCIs, once again, standardized within 6 feet or less, from any of our sinks out here. So anytime you have a receptacle in there, GFCI it. So what about our next one there, Randy? Let's see, crawl spaces. This came about. We've always had receptacles down there been protected. They've been GFCI. That's not new. What has happened, though, we've have these outlets, our lighting outlets, that kind of escaped, I guess, from being protected. What happened is someone got injured or killed, I can't remember exactly, and by backing into a broken lighting outlet. And so because of this, we got a new block of code here says that also the crawl space lighting outlets now have to be GFCI protected. So not only receptacles, now the lighting outlets are out here in the crawl spaces are protected as well. And it makes good sense working under there. And I know we've all crawled around in those places and gotten against stuff. It's nice to have the lights, but you take a look at the picture right there. You see just open lamps there. Very easily to break them off. And I know we've all done that at one time or another. So a little bit safer. So let's try our next one, Randy. What do we got there? Garage circuits. We've always had GFCIs out in the garage circuits. What they've done, this has gone on into branch circuits now. They're actually wanting a 20 amp dedicated circuit out there. We've always said, yes, there is a branch circuit out in the garage. Now we want one that must be a 20 ampere circuit. Why? Well, we got lots of stuff we plug into the equipment out there, so we're looking at more usage of this circuit all the time and greater demands on it. So let's put it, let's make it out here to a 20. So next one out here we see is our basements, garages, accessory buildings, and a point for garages. Out here is the receptacles are to be located at each bay now. Okay, not more than 5.5 feet above the floor. So, what they're saying is, hey, put an outlet out there everywhere you got a car bay. Basically, for you and I, it's probably every garage door out there. So it gives us a outlet in, reasonably close for us to be able to work on it, to be able to connect to it, put a battery charger on it. Who knows what all we do with that guy right there. So, but we're trying to, make it address, and you and I know how many places have we plugged in cords in the garage and had them drug all over the floor. And so here we go to try and help that one. So let's take a look at our next one out here. This is meeting rooms. Meeting rooms have had an interesting change out there because, once again, here's our problems with where are the outlets? Do we need to plug into them? Are they in the floor? Is it a broken floor pocket? Is there enough on the walls? And where are they? Somebody put up a divider. We can't get to it. So, hey, here is an effort to standardize outlets for meeting rooms. There's some requirements. If you've got a room over 215 square feet, you've got at least one receptacle within 6 feet of any fixed wall. Well, this is beginning to sound like what we had in 210.52, which is, receptacle location, and actually that's where it becomes. So once again, we've got the wall, the wall outlet space on that. Plus, you're also allowed to put a floor pocket in within 6 foot of the outside wall and count it as one of those as well. So those of you who are in and doing new meeting rooms and so on, look at the outlets, see where they got to go. There are some new standards for that one as well. So what's our next one up there, Randy? Electrodes permitted for grounding. This is a little bit of a redefinition within this one, and we've taken away, you cannot use the metal frame of the building, but you can still use any other metal that is in direct connection with the earth itself. So pilings, etc., like that. But what they're trying to get you away from is, say, for example, I've got a metal-clad building, and connecting onto that and say, okay, it hooks onto the beams, it hooks onto the pillars, etc., pilings. Is it a grounding support structure? And they're saying, yeah, there's a little bit of a question mark about that. And so they've tried to redefine that better for a more direct connection to Earth to be established. We look at the next slide there, you'll see a little bit more in defining it. It said there must be at least 10 feet or more in direct contact with the Earth. So, you know, obviously, the sheet metal structure on the outside of the building is not going to have that kind of connectability out there. And you see the notes down there. We're talking about things like pilings, casings, other structural metals. So, once again, we're defining and making our grounding structures better in our construction as within our construction industry out here. So, what do we got next, Randy?
Well, that moves us into 310.15. And as you mentioned, Mel, in the last webinar, they have deleted the rooftop adder table. I don't know if I should say famous or infamous, whatever it is, but
yes.
Certainly been a lot of discussion about that table over the last couple of code editions. But anyway, that's been gone. However, all the requirements haven't gone away. The requirements still are going to be that it says, if you look at that first bullet, it says that the raceway of the cable shall be installed at a minimum above the roof of 7/8 of an inch. And then that second bullet says, well, if you can't make that 7/8 of an inch, you have to use that rooftop adder, that was from the old table now, of 60 degrees Fahrenheit, has to be added to your outdoor temperature. Well, if you've done any of those ampacity calculations, you know you can really end up having to upsize your conductors if you lay those cables and you have all those conduits on the rooftop. I'm thinking is what most often happens. But generally thinking, you know, if you think about it, I mean, usually most cases you block those up, don't you? You can't always build a support structure on a rooftop because we don't like to make penetrations into our roofs. But you may use 2x4s or typically 4x4s to block those conduits up. I think where we're going to have to be careful, though, is maybe when we transition out of that conduit with some type of flex to go maybe up to a rooftop unit or whatever is my equipment up there, we're going to have to be careful and not lay those flexible conduits right on the rooftop. We need to be sure that they're supported up properly as well. The next item is auxiliary gutters. It says new for 366. It's the article for auxiliary gutters. But you'll see down there at the bottom right of the slide, it also applies to 376, the article on metal wireways, and article 378 for non-metallic wireways. And let's do a quick little poll question again, just for kicks, and see that how many of you, when you run wires through auxiliary gutters and wireways, you actually take and you group conductors together and maybe put a tie wrap around all of the A, B's, and C's so that your phase A conductors aren't laying on one side of the wireway and phase B and C on another side, and then you end up with inductive heating. And that's become an issue. And there was actually a case, there was a fire, because that's exactly what happened. Just when somebody was routing the conductors through the wireway, they put too many of one phase on a certain side of the wireway, inductive heating, and it caused a fire. So I'm going to go ahead and give you about 3 more seconds, and then I'll close the poll, and we'll look at the results. And pretty close, pretty close. But this is going to be the new requirement, then, is what it's talking about. We want to take all of our A, B, and C conductors and put them together, and probably tie wraps is the best way to do that. We already know we have to do that in conduits, right? And it makes a reference to that. It goes up and it says that we still have to comply with 310.10h. Well, 310.10h, that's my requirements. You know, all my conductors have to be the same length, the same size, and conductor material, the same type insulation. I terminate them in the same manner and so forth. But now when I go through these auxiliary gutters and wireways, I'm also going to have to group those conductors together, just like I don't run through a conduit, or when I do run through a conduit, I put A, B, and C in each one of my conduits. So I'll group that in my gutters and waterways as well then.
Randy, you might want to note on that to also be sure the neutral's got to be in there too.
Oh, yeah, yeah. Yep, exactly. Let's change our picture, huh? Show that. Yeah, anyway.
This guy.
Yeah. Switches. This is kind of an interesting one as we move into 404. And probably one of the biggest culprits here is that sensor switch that we have in our rooms that automatically turns the lights on when we walk in. You think about that. If that switch is going to remain, or if it's going to work, that little electronic sensor has to always be energized so that it can sense when we walk in the room. So if I didn't pull a neutral conductor, a grounded conductor, in other words, into my switch box, now I have an ungrounded conductor, but I don't have a return conductor to keep that little sensor energized. So what the manufacturers have told us in the past, some manufacturers, they say, hey, look, just go ahead and take that return wire off of the sensor and connect that to the equipment grounding conductor, the green or the bare copper wire. We know we're not supposed to do things like that. We don't want to use that equipment grounding conductor for a normal return path or normal path of current flow. So there's a change. And we should be pulling that grounded conductor into our switches now. But anyway, these electronic switches will have to be listed. They cannot, and the requirement is that they cannot introduce any current onto the equipment grounding conductor. And to give the manufacturer some time to get caught up here, and we'll see this in the code once in a while, we'll put something into the code, but we'll say it's not going to be effective until a certain date. So this one will become effective with the 2020 code, which will be our next edition, becomes effective January 1st of 2020. This appeared first in the last edition, the 2014 edition of the code, I do believe. And this is for receptacles that are controlled by our energy management systems, for example, where I have certain receptacles in my building that are going to shut off at 7 p.m. or 9 p.m. or whatever it is. And so I want to know that receptacle is going to shut off, because maybe I don't want to plug I don't know, a fax machine into it if I'm expecting faxes during the night, or if I have any type of important loads I don't want to accidentally de-energize. Do not plug them into one of these controlled receptacles. So we came up with, or they came up with for the last edition of the code, to use the international symbol for off and on, which is that little circle with the line through it, and to put that either in the last edition of the code, it could be either on the faceplate or on the receptacle itself. Well, now that little international symbol will have to be on the receptacle itself, and on each device of the receptacle that is being switched. So if you think about it, you could, I suppose, on that particular receptacle, you may break off that tab on the ungrounded side, and you could have the top half of the receptacle controlled and the bottom half not controlled, I suppose. But anyway, so each device on the yoke is going to have to be marked with that international symbol. And then there was some public input that said, look, not everybody knows what that little symbol means when they see it on the receptacle. So let's put the words controlled on there. And so you can see the words controlled on that face of that receptacle. I think probably the challenge there people have brought up is like, you know, really? You're going to print something on the receptacle that people are actually going to be able to read? So I don't know. I'm sure you can, but there's not a whole lot of space there. And then we've seen a change on the tamper-resistant receptacles. No surprise here. The reason that tamper-resistant receptacles came out in the first place, one of the public inputs was that in 1 year we had 11,000 children in the United States receive a treatment in emergency rooms, or emergency medical treatment, for having put something into a receptacle, which I thought was like, really, I would have guessed maybe a couple hundred or a few hundred or something, but 11,000 children in 1 year had been affected by receptacles, so not good. So they came out with the tamper-resistant receptacles, and it applies to dwelling units, and we had to put them in guest rooms and suites of hotels and motels and in child care facilities. But now they're expanding those requirements, and if you think, where would you expand them to? And it's, well, I guess wherever you got kids, huh? So preschools, elementary schools, business offices, waiting rooms and medical offices and so forth. Number 6, it says references us to Article 518, which is on places of assembly. And 518.2 is actually a list of, I don't know, probably 15 or 20 different assembly occupancies, like gymnasium and skating rinks and auditoriums and so on, of where these locations for the tamper-resistant receptacles would apply. And then also number 7 on dormitories, we're going to require tamper-resistant receptacles. And I think, yeah, those kids should be old enough by that point, shouldn't they? But anyway, okay. So I'll turn it back over to Mel, and he'll take a look at 408 for us.
Yeah, 408 is an existing document out there. What's new in it is service panel boards here. And what they're talking about here is the placement now of, in all service panel boards, of a covering to prevent anyone from touching it. So what they're doing there, make sure that there's no longer any uninsulated, ungrounded bus bars or service terminals that were exposed to inadvertent contact. Well, okay, that makes sense. That was always that first piece of equipment or first piece of gear that is when we put in a new panel, we threw that away. Well, you got to hang on to that now, as well as they're going to make a more permanent installation with these as well. So I remember many times having, yeah, what the heck with this? Like, we'll get rid of that. We don't need it. But anyway, so if there are if this goes into a service panel board, such as an MCC type controls or anything like that, more than one service, then this is this provision does not apply to that. It's kind of interesting. I love to watch the guy Mike Holmes on TV, who operates out of Canada, and I'll look at the panel boards and things they have there. They've already got all these covers on it, so it's kind of interesting to actually see, yes, the equipment is available. We just haven't done it here in the States. So, but anyway, covers on now are applicable to panel boards. So what do we got next out here, Randy? Short circuit current available. This keeps coming again and again out here. We are expanding constantly awareness of everybody. What is the available fault current? A lot of this has to deal with now is the equipment rated for that fault current as well. Can it withstand that fault rating? And so here we are again. Here is a warning label at a motor control center in 430.99 here. So what is the available fault current? It's a basic label. It's just going to give you the maximum fault current. In this case, we've got, what, 48,000 amps. Gives you the date when it was done. The case of the engineering company as well out here. So we're trying to help out the inspectors, trying to help out everybody's safety across the board, and so you're going to see this coming through the code in other areas as well. But here you go. Here's a label on an MCC out here giving you available fault current. So I think that's about it, except for some of our program stuff. What you got there, Randy?
We've pretty well hit. We've hit a lot of the big topics in chapters 1 through 4. We've still got more to go through, and I know a lot of you have probably been to our code classes in the past. It just shows generally what we have to offer in way of training on the National Electrical Code. Starting over maybe at that 10 o'clock position is where we are right now. We're talking about the changes to the 2017 National Electrical Code. Normally we teach this as a 2-day class, and it gives us a chance to analyze the changes, look at what did it say before, why did it change, and then the thing we really haven't been able to get into today in these short sessions is how does that apply to you out in the field, and what are some of the typical things that you're going to run into when you're doing the work out there and so forth. Then at the top we have our regular National Electrical Code class, a 3-day class that has been very popular, and it's good for the beginner. It's good for the journeyman and master electrician. We go into it just as deep as we can in 3 days, and we can cover a lot of material in 3 days. And we also are offering a new class this year over there about the 2 o'clock position, Changes in Practical Applications. It's a workshop. We're going to do lots of exercises, and it's going to cover the distribution systems and facilities. So rather than just go through the code book, we're going to look at the practical side of it and work through a lot of problems in that class. We also have our class on grounding and bonding, where we talk just about Article 250 and everything that goes into Article 250. And then our hazardous classified locations is also a separate class offering. That one we cover in our public classes out in our hotels. We cover all 3 classified locations, Class 1, 2, and 3. We go a lot out to facilities and teach that specific class because people we only have Class 1 locations or Class 2 locations or whatever. So we're able to stick to these specific types of materials that you have. And also the good stuff, you get a discount if you'd like to sign up for one of our classes. You can either call or go online to do that. There is the discount code that you need up above that where it says webinar EC17 is the key word there for you. So that's a pretty significant discount, $150. Or you can call the office and talk to them about that, or if you want to bring us on site, Mel or I or many other instructors we have to do any of this training, you can call and get some special pricing on that for having attended the webinar. So the next webinar is scheduled for August the 18th. We're going to go through chapters 5 through 8. Also, we're going to cover the new articles. Now, one of those new articles was in chapter 4, and we just went through chapters 1 through 4, but we just don't have time to go through that article today. So we're going to hit that on August the 18th, and by then we will have our PDF versions of the code. It will be, less than a week away from that date until the code will become an ANSI approved standard and available for adoption. So, I'd like to thank everyone for attending. If you have a great day.
Hey,
if there are any questions.
Yeah, if I can jump in here, guys. This is Brett again. So we had a few questions coming through, and I'm going to do my best to translate them for you. So the first one comes in and asks, could there be a requirement in the next NEC for individually fused fixtures on emergency egress lighting circuits that aren't on battery backup? I think they were saying this is, if so, any of the fixture. If so, any one fixture shorts out during emergency conditions, it won't take out the whole bank of emergency egress lighting and so forth. So is that something that would be addressed?
Thinking I have not seen anything on that. Have you, Mel?
I've not seen anything on it either. It may, the other problem we have is it may pop up in a different code because that, a standard like that, that'll pop up in some of the ANSI standards on equipment. Or something. Yes. Yeah. More so in life safety, your life safety 101 codes and so on. It could come out in equipment design, NFPA 97 codes out there, as well as obviously NFPA 70, our National Electric Code. So we got several different sources. It's not presently anywhere in the NEC.
Okay.
So it's not to say that it can't have, but you're going to have to keep an eye on it because, as I said, it can also appear as an ANSI standard as a byproduct of something maybe OSHA has asked for.
Sure.
Yeah. I mentioned too, keep in mind they're going to open up the public input for the 2020 code here shortly, as soon as they get this one out on the street. So that something like that might be a good idea and certainly be worth submitting to the codes to some public input, which is all done online now. Very simple to do. Anyway, yeah. Another question? Or?
Yeah, so question 2, I have a couple more. The question 2 would be kind of on the labeling side. So the revised arc flash labeling are different than the current labeling requirements for NFPA 70E. Will the NFPA 70E labeling requirements be revised to agree with the new NFPA 70 labeling requirements?
that has been kicked around a lot. I can tell you there was a lot of discussion about that, yeah, hey, wait, these labels don't comply with 70E. We really won't know on 70E until this next year. In 2017, we'll see the 2018 edition of 70E get finalized. So I don't have an answer for you right now. I don't know unless you have heard something on it, Mel.
I don't. The only thing I have seen is the NEC tends to stick to the equipment and equipment safety, where 70E is going out and protecting you and I out there when we're working with the gear, and so the labeling tends to reflect that. Where we just saw out in chapter 4, the new one, talking about, well, the labeling on the MCCs, which was, we're putting out here what's the fault potential. Well, that has to do with, to me, in terms of engineering and equipment, more so than me walking up and opening up that box. So, do we have, and I really think we do have a different kind of look between 70E and the actual National Electric Code.
Thank you. And the last one here comes in. Do you need to put, this kind of goes back to the receptacles, but do you need to put this controlled receptacle on all switch plugs in residential dwellings?
No.
Okay.
No.
Well, there you have it. I wanted to address a few others. There was some questions that came in that said, are these all of the changes for chapters 1 through 4? Is this everything, or is there more?
Oh, no, they're
absolutely not.
Yeah, we see. Just to give you an idea, that a few of the other items that come to mind, there's going to be a requirement for labeling of reconditioned equipment. We have trouble meeting workings or dedicated equipment space requirements sometimes on outdoor equipment because of overhangs of porches and buildings and so forth, so that's going to be taken care of. Another big one I can think of right off will be back in 110, and it's going to be on the requirements for some pre-energization testing on equipment. We've got more changes we'll see on motors. So, yeah, there's quite a few more changes.
Excellent. And then I'll roll in. We were talking about this before the webinar, Mel and Randy, but just to remind folks, when would some of this information, be officially released to the public?
Yeah, well, like we said, we're looking the standards. We say these are all proposed changes until the Standards Council. So the technical councils have met, committees are meeting or are in the process of meeting. They will send all of their final information to the Standards Council, and then by August the 4th, or on August the 4th, the Standards Council is scheduled to go ahead and issue and publish the code. About a week later, on August the 10th, you'll be able to download it from the NFPA website as a PDF. And then on the 24th of August, we say, ANSI will approve the 2017 NEC, and it will then be available, or then, jurisdictions will be able to adopt it. And then we will see on September the 1st is when the hard copy of the code book is scheduled to be out.
Perfect. So I want to address, those are all kind of the questions coming in technically. I saw some questions coming in from folks asking about if you missed some of this webinar or if you got on late, will this session be available as recording later? The answer is yes. We are working on getting those updated and to the public. They will most likely be released at the end of this webinar series. So as Mel and Randy mentioned, webinar 3 will be August 18th. Once we complete that, we will then be releasing all of the recordings from webinars 1 through 3 to the public, and we'll be sharing those most likely on our website, and then we'll also be doing an email campaign that would share them to you folks. So everyone that has attended would have access to that. We will have your information. So No worries on that. We'll make sure we get those available. And lastly, there was one question coming in about certification for attending today's webinar. Unfortunately, this is just a webinar from NTT to our clients, to our audience. So certification would not be granted through us. That would be internally, if there's any requirements or standards for your own organization. Otherwise, we will be, I think that's it for me. Mel, Randy, anything else on your end as far as...
Just stay safe out there.
Excellent, guys. Well, hey, folks, we really appreciate your attendance. As Randy had mentioned, we do have that discount code for any self-registrations on the website, or feel free to call into NTT at any time, reference the webinar, and our customer service department can get you set up for any class on-site or regional that you may be looking for. In the meantime, we'll see you August 18th. Thank you for attending. Thank you, Mel and Randy.
Thank you.
Have a great day. Bye now.